Hello students, in this video we will be solving three problems under exercise 8.4 and from question number 5, which is prove the following identities. So we have to prove our first problem, which means which says cos A minus sin A plus 1 upon cos A plus sin A minus 1 equal to cosec A plus cot A. We need to prove left hand side equal to right hand side. Let's begin with the left hand side, which says the left hand side equal to cos A minus sin A plus 1 whole thing upon cos A plus sin A minus 1. Now this is in the simplest form, so we'll have to do something in order to get to this form. What we'll do, if you notice both of these, cosec A and cot A, cosec is what? 1 upon sin A. It can be written as 1 upon sin A, and cot A can be written as cos A upon sin A, which means we need sin A in both cases. So what we'll do is, both the numerator as well as the denominator, will divide them with sin A. Let's see where we get cos A minus sin A plus 1 upon sin A whole thing upon cos A plus sin A minus 1 upon sin A. There is a small part which I have not mentioned over here. We need to solve this particular identity using another identity. So that is using identity cosec square A equal to 1 plus cot square A. In fact, we have learned this particular identity when we drew the regular hexagon, if you recall. Okay. So this particular problem says we need to use this particular identity cosec square A equal to 1 plus cot square A. So at some point of time we will get this cosec square A, and in place of cosec square A we will have to substitute it with 1 plus cot square A, or we will be having 1 plus cot square A. In place of that we will have to substitute with cosec square A. We will see when we get to that. So now we have taken sin A both places, so it is balanced. Okay. So what next can we do from here? So what best I can see over here is, we'll take out each and every term and we'll divide it with sin A. I'll show you how. Okay. So cos A, we'll write it cos A upon sin A. Then this is the numerator I am talking about, minus sin A upon sin A plus 1 upon sin A. I will do the same for our denominator as well. Okay. So you write cos A upon sin A plus sin A upon sin A minus, this would be minus 1 upon sin A. Fine. So I have just listed it down separately. Now we will see what we can cancel. So sin A can cancel here, sin A can solve it over here. I will write down what is cos A upon sin A. It is cot A. This would be minus 1 plus 1 upon sin A, which is nothing but cosec A. Whole thing upon, again cos A upon sin A is cot A plus 1 minus cosec A. Okay. But the numerator, I am looking in to replace this 1 which is here with this. So we know that cosec square A is equal to 1 plus cot square A. Okay, so cosec square A, I'll write it over here, is equal to 1 plus cot square A. So if I want to replace 1 with the ratios over here, so all this will become with cosec square A minus cot square A equal to 1. You see, cot square A, I brought it to the left hand side and it became negative. So cosec square a minus cot square a gives us 1. So this one I'm going to replace with cosec square a minus cot square a. So I'll put down the cot a and I'll take the cosec a separately here, and in place of minus 1 I'm going to put this down. Okay, so minus sign I'll keep it outside, and instead of the 1 I'll put 1 is equal to cosec square a minus cot square a, because that's what we are asked. We are asked to prove left hand side equal to right hand side using this particular identity, and we are doing just that. We are using this identity in this problem. So instead of 1 I have replaced it with minus. So minus sign is outside. I have not applied it to this bracket because this was minus 1. So this is in place of 1. So the minus sign applies to both of them. So whole thing upon cot a plus 1 minus cosec a. So now from here cot a plus cosec a minus cosec square a minus cot square a. I will not open this bracket, but if you have a look, this is nothing but a square b minus b square b, which we can write as a plus b into a minus b. So cot a, I'll write it the way it is, cosec a is the same, and in place of cosec square a minus cot a, I'm going to write it as cosec a plus cot a into cosec a minus cot a. Whole thing upon cot a plus 1 minus cosec a. Now if you have a look between these two terms, okay, and these two terms, what is common between the two? It is cot a plus cosec a plus cot a. These two terms can be taken common. If we take it out common between this term and this term, we are left with, I'll take this out first, cot a plus cosec a. So then in place of this we are left with 1 minus this particular term, that is minus cosec a plus cot a. Close the bracket. Whole thing upon, and this I'll just rearrange it so it looks familiar to it. Plus 1 I'll write over here, followed by minus cosec a plus cot a. Okay. This and this, the numerator is the same, I've just rearranged it. I wrote 1 over here, minus cosec over here, and cot a over here. Why have I done that? Because if you have a look, this and this particular term in the numerator can now cancel out each other, and we are left with then cot a plus cosec a. What we needed in the right hand side, cosec a plus cot a. So this is equal to RHS. Okay, so finished proving it. In our next problem we have to prove root of 1 plus sin a upon 1 minus sin a equal to sec a plus tan a. We will take left hand side, which is equal to square root of 1 plus sin a upon 1 minus sin a. So we will go ahead to actually rationalize this thing. So what we will do is we will keep 1 plus sin a this way upon 1 minus sin a, and we will multiply it with the opposite sign, 1 plus sin a. How we do for rationalization, 1 plus sin a. Okay, so square root of 1 plus sin a into 1 plus sin a we get as 1 plus sin a whole square, and 1 minus sin a into 1 plus sin a. This is a minus b into a plus b. We get a square minus b square. Okay, write it this way once again, 1 plus sin a whole square, and 1 minus sin square a is nothing but cos square a. You can write over here 1 minus sin square a equal to cos square A. Complete the problem over here. So now, since both are squares, numerator as well as denominator, we can apply the root sign. It gets cancelled and we are left with left hand side equal to 1 plus sin A upon cos A. But we need sec A plus tan A. We can get this from here. We separate out the two numerators with separate denominators. 1 upon this we can write as 1 upon cos A plus sin A upon cos A. 1 upon cos A is sec A and sin upon cos A is tan A. Exactly what we need for our right hand side. That's proved. Next problem is sin theta minus 2 sin cube theta whole thing upon 2 cos cube theta minus cos theta, and we need to prove it equal to tan theta. We start with the left hand side, which is equal to sin theta minus 2 sin cube theta whole thing upon 2 cos cube theta minus cos theta. So in this case, what I will try to do, in the numerator we will try to take sin theta common, because clearly sin theta is common to both these terms. We will be left with 1 minus 2 sin square theta. Similarly, in the denominator, cos theta is common to both these terms. So I will take cos theta common. We are left with 2 cos square theta minus 1. Sin theta cos theta is what? Sin theta upon cos theta is tan theta. I'll leave 1 minus 2 sin square theta the way it is. And in the numerator, now that I have only 2 cos square theta minus 1 left, I'll try to convert cos square theta to sin square theta. So we can do that as 2 into, instead of cos square theta, I'll put 1 minus sin square theta. So I'll put the reason over here. It's important to put the reason to know from which identity that you have used. Okay, so cos square theta equal to 1 minus sin square theta. Do not assume that the examiner knows it. It is important that you mention or give reason for the change that you have done. Okay, complete it over here. So left hand side equal to tan theta, write it the way it is, into 1 minus 2 sin square theta. So this hasn't changed. Whole thing upon, now we've got 2, put this in brackets, 2 into 1 minus sin square theta minus. I'll put the 2 inside. Okay, so I'll take the 2 inside. I get 2 into 1 gives us 2. 2 into minus sin square gives us minus 2 sin square theta minus 1. Okay, so once again tan theta remains the way it is, 1 minus 2 sin square theta whole thing upon, now 2 minus 1 is what? 1. And we are left with 1 minus 2 sin square theta. If you have a look, 1 minus 2 sin square theta and 1 minus 2 sin square theta, we've got them both in the numerator and denominator. Both cancel out. We are left with tan theta, which is equal to our right hand side. Okay. So with this we have completed 3 problems under exercise 8.4, question number 5 in this video. If you have liked watching this video, please click the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon to receive notification whenever a new video is posted. Thanks for watching. See you in the next video.